Question 3, which expression is equivalent to this polynomial? So we can see from, so first off, the thing that I will notice in this problem is we have 9x squared plus 7. This is a polynomial that traditionally can't be factored because it is, first off, those aren't two perfect squares because 7 is not a perfect square, and it's a sum of two perfect squares. So my antennas are up on this problem, which tells me the answer is probably going to involve an imaginary number somehow. So it's probably going to be this one or this one. So I'm going to start there. I'm going to work these backwards, and I'm going to start with this answer choice, and I'm going to see if by multiplying that answer choice together, I end up getting 9x squared plus 7. So I'm going to reverse engineer this problem. So the first thing we notice, when we square something, that means we're multiplying it by itself. So I'm going to rewrite this answer choice as 3x minus the square root of 7i. Notice the I is on the outside of the square root, multiplied by itself, because that's what squaring something means. You're multiplying it by itself. So I'm going to first take 3x and multiply it by 3x. And that gives me 9x squared. Then 3x times negative radical 7i. This one's going to be a mouthful, but it's going to be negative 3x radical 7i. We could put the x and the I together if we wanted, but I'm not going to at this time. Then I'm going to distribute the negative radical 7 and multiply it by 3x. That's also going to give me negative 3x radical 7i. Again, we could put the radical 7i first, but I'm going to keep it consistent with this term and put the portion with the x first. And then finally, negative radical 7i times negative radical 7i is a positive radical 49 I squared. A couple things to remember. I squared is equivalent to negative 1. So let's simplify this a little bit further. 9x squared, I'm going to bring down. It has no like terms. These terms here in the middle, those are like terms because they have the exact same variable. So we can combine these, and that will give us negative 6x radical 7i. And then here on the end, the square root of 49 is 7. I squared, we're going to replace it with negative 1. We can see clearly this isn't going to work because the only step left here is change that 7 times negative 1 to a minus 7. And that does not match up with that. So let's take this last answer choice. I'm going to rewrite it just so I have more space. 3x plus radical 7i multiplied by 3x minus radical 7i. Let's distribute 3x times 3x, 9x squared. 3x times negative radical 7i is negative 3x radical 7i. And let's just do purple again. I'm going to erase these so it doesn't get confusing. But I'm going to take radical 7i times 3x, and this time it's positive 3x radical 7i. And then finally, radical 7i times negative radical 7i is negative radical 49 I squared. These terms in the middle, notice they're the exact same thing, except one's positive, one's negative. So these are going to cancel out. We're left with 9x squared. The square root of 49 is 7. So it's 9x squared minus 7. We're going to replace the I squared here with -1. And that -7 times that -1 becomes a +7. So 9x squared plus 7 is the end result, which matches the original problem. So that means we have our answer.